Hello again. This time we're going to be going through lecture 2. There are a number of exercises that are all indicated by this little screen here with the monitor and some text. And so I'm just going to be going through the coding exercises that are listed on each of these pages. If you want access to the slides, you should be able to see them on Canvas, but I'm just going to be focusing on the coding stuff for these videos. So let's write a program that demonstrates the difference between integer division and floating point division in C++. Well, the first question we want to ask ourselves is, what is the difference between integer division and floating point division in C++? And probably the easiest way to figure it out is to just try doing some division. Now, hello world is not really going to help me too much, so let's actually make some variables and try dividing things. So let's make a variable called my integer. I'll make a floating point variable called my float. Let's give them some values. I'm going to pick 101 for fun, and my floating point number is going to be, let's say, 60.5, and just threw some numbers out there. Now, we want to figure out what's going on with our integer division. So let's try doing some division and see what happens. So in order to do some calculations, I have a couple options. I can either compute directly a division and then print it out, or I can store the result in some kind of variable. Now, since I don't really know what's going to happen, theoretically, if I were to divide this by 25 or something like that, what I'm actually going to do is I'm going to do the calculation and print out the result of that calculation using cout. So we saw from the last video cout. I want to redirect it something to print. Now, just to clearly make it obvious, you can just print out a variable. So I have an integer variable called my integer. It has the value of 101. If I were to send that to cout to print, let's see what that does. Look at that, it prints out 101, kind of like I want. Similarly, if I print out my float, 60.5, which is the value of my float. Okay, now, what if I want to do some division and see what happens? Let's take my integer. We're going to divide that by 25. So what should be our result? 101 divided by 25 is 4 point something. Let's see what actually happens if I do this division. I didn't get 4 point something. I just got 4. So the idea behind integer division in C specifically, is that any time that you do division, you just cut the remainder away completely. So let me show you another example. For instance, keeping it real simple, I can actually just say 5 divided by 2. This is 2.5, right? Well, is it 2.5? The C++ just tells me it's 2. And this is because if you were to take 5 and divide 2 into it as many times as possible, you can put 2 2's into 5 before you have a remainder. And that remainder just gets tossed away. Now, what happens with floating point numbers? Let's say I took my 60.5, so that's my float, and I divided by 3. I'm definitely not going to divide in evenly because I got a nice little 0.5 here. And look at that, 20.166. I'm guessing this goes further, has more 6's. I'm not quite totally sure, but we can talk about that in another exercise. But what we notice here right away is that unlike the integer division, the remainder is actually kept around here. So we can see that there is a decimal point remaining, which should be the result of our calculation. Similarly, if I actually were to take my integer, let's take my float and make it the same value. So we'll do my float 101, and we'll divide that by 25, which I said should give us 4 point something, right? 4.04 it seems. I guess that makes sense, right? 0.04 times 25 should give me 1, the one that's left over, and look at that. Now, it looks like these both should give you the same answer, right? But because my float has been specified to be a floating point number, when I calculate the result of that divided by 25, C++ says, oh, you're trying to divide something that could be a fraction by another number. I'm going to make sure that you still get to have your remainder here. Because if I put this back to my integer, C++ says, oh, you're dividing an integer by another integer. I'm just going to take this the fast way. Any remainders that are there, just going to get cut away and leave you with only the 4. So this is the first program. Now, let's take a look at the second one. Okay, keyboard input and output. Write a program that can read in a number and print out the next one. Shouldn't be too hard for us. So the new thing that we need for this one is called cin. We need to be able to get input from the keyboard. We're going to take, ask for a number, right? So when it says a number, generally we mean integer, but floating point would be totally fine. I think we're just going to read in an integer, though. So my integer, we're going to read in a value for that, and we're going to print out the next one. Okay, not too difficult. So with cout, if you remember, we were taking cout and we were directing stuff into cout. Now, if we want to get input from the keyboard, that means we want to bring stuff out of the cin. So I got my integer. Now I need to take stuff from the input and send it into my integer. Now this is going to work perfectly okay, but I want to emphasize right here something that's important for good code design, which is any time that you're asking somebody to type something in for your program to work, you should tell them that you're asking them for something and prompt them with a clear indication of what it is you're asking for. So before we even ask them to give us our number, we're going to ask them to give us a number. And we're going to write, please enter a number with a colon. Now it should, and I guess we'll output my integer just to make sure everything works. So I'm going to declare an integer. I don't have a value for it yet. I'm going to tell whoever's running my program that I need a number. They're going to enter it, and then that number is going to get printed out to the screen. So let's try it. Please enter a number. Enter 5,000. Hit enter, and it printed me back 5,000. Great. Now, it did say, though, that I have to print out the subsequent number. So not only do I need to get the number back, but I need to return 5,001. I need to print that out to the screen because we're looking for what's the next number. So the next number, and we can actually be very verbose with this and make it super explicit by saying the next number is, and combine that with the next number, which is my integer plus 1. So although this line is looking kind of chunky right now, all it's doing is printing out the message. The next number is, I should put a space here, and the next number is the number that I got, my integer plus 1. And this calculation, just like in mathematics where you have PEMDAS or BEDMAS or whatever you like to call it, anything that's within parentheses is has operations that go first. So by doing this, I'm saying take my integer, add 1 to it, and that is what's going to get passed over to cout. So I run things, enter a number, 5,000. The next number is 5,001, and that's it. Okay, let's take a look at our next problem. Putting it all together, write a program that reads in a character from the keyboard input and then prints the integer value of that character. So we've already got a good chunk of that, some of the things we're going to need to do here. Reading in something from the keyboard, printing something out. We've already got some of that going on here, but we'll need to do a few changes. First off, we're not going to be getting a number anymore. We're asking for a character. So instead of my integer, I want to have my character. We're going to have to call it, we'll declare that it's a character. We're going to store their character into that variable. And now, instead of printing out the subsequent number, because we don't have a number anymore, we want to print the integer value of that character. So we need to figure out what is the integer value of a character. Well, the integer value of that character is, and now if I just print out the character, I'm just going to get the character. I want to figure out what the integer value of it is. So I'm going to take my character and turn it into an integer. And then let's see what happens if I do this. So I'm going to enter A. The integer value of that character is 65. This seems kind of arbitrary, right? Like, where the heck did a 65 come from? But it turns out there's actually a handy dandy table that you can reference to figure out what the integer value of any character is. And I'm going to pull it up for you by Google searching it. And it's called the ASCII table. This is American Standard Code for Information Interchange. And essentially, I hope this is the right table. I think so. Yes. This little table is a link between an integer value on the left and what the character is on the right. Now, the first bunch of these are all special symbols, things like null, non-existent, end of line, that kind of thing. However, if you notice, 65 here is the letter A that I was looking for. And so anytime that you need to be able to convert between the integer value of something and a character, you can use this table to do it really quickly. You may also have seen at some point in your life, some binary code, zeros and ones across the screen. It turns out once you know how to convert binary into integer values, the binary number representation of any of these integers also represents the appropriate character. So all those zeros and ones streaming down actually can be converted if you take those numbers, make them into integers, and then turn those into letters into a message, which I thought is kind of cool. So I think that's everything for this question, and then we'll move on to our final exercise. Okay, so our last exercise of the day. Write a program that prints out a double variable as a dollar amount rounded to 2 decimal places. Okay, so instead of working with characters and integers, we're now working with a double. Maybe now is not a bad time to talk about the difference. I guess I'll talk about the difference between a double and a float after I've gotten this thing to work. So first off, instead of my character, it's going to be my double. I ask them to enter a double number. Double, and I want to round to 2 decimal places. So the double rounded to 2 decimal places is... Okay, and now here's where we have to think about things before we go ahead and code things really quickly. If I just enter my double, this is obviously not going to give me things rounded to 2 decimal places, and I can verify that that's the case by entering something like 6.6666, and clearly this has not been rounded yet. There's a couple different ways that we can solve this problem. I'm going to start with the trickier way first. When I say trickier, it requires more steps, but you can do this with the knowledge that you have so far. And so what we're going to do is we're going to take advantage of the fact that that integer division cuts off remainders. So our goal here is to be able to print out 6.66 or 6.67, depending on if you care about rounding to the nearest number or just cutting off the digits. Now, if we want to print out 6.66, that means that we want to take advantage of the fact that integer division is going to cut off extra decimals by switching this number into 666. That way we have these 2 decimal places are going to be kept, and then we'll cut off the last part here. So here's how we're going to do that. We're going to temporarily make a new variable, and we're going to call it modified double. And what this is going to be equal to is if we took my double and multiplied it by 100. This is not the symbol you may be expecting when it comes to multiplication. Usually you expect to see x, but x is a character, which means that it's not going to be recognized by C++ as multiplication. So we're going to multiply my double by 100. And now this means that my double, or modified double, should have a value of 666.66. Now I want to cut off that last 0.66, those last couple of digits. So I'm actually going to take this, and I'm going to convert it into an integer. So int modified integer is just going to be the integer version of my double. Now my 666.66 is just 666. So now I need to reverse the fact that I multiplied it by 100. So my modified double is going to be my modified integer divided by 100. So just to keep track of how everything is going in here, what I think I'm going to do is I'm actually just going to print out each of these so we can see what the values are as we go through. So we're going to comment this out to hang on to it for a little later, but I want to look at what these numbers are so I can make sure I'm not getting lost in the values here. Anytime that you're unsure of what your code should be doing, it's really helpful to put in some of these extra statements just to print out the values of things so you're confident that you know what's going on. So let's output the value of my modified double is a modified double. Put a new line. And then we'll do the same thing for the modified integer, and then for the modified double again. Integer. You don't have to add these lines in, but because I want to make sure I know exactly what my code is doing, I'm going to put them in so we can follow along very clearly. Okay, so I'm going to run. Let's just enter lots of extra decimal places. Okay, so what happens as I go through? I think I may have made a mistake, and you know what? That's okay. We're going to fix it. So the value of my modified double is 666.667. You'll notice that clearly there was already a rounding error here. It should have kept more of the sixes, but it turns out that doubles and floats can only actually store a certain amount of information in them, meaning that sometimes you're going to get this kind of rounding issue. You'll learn more about exactly how this kind of rounding stuff works later on in computer science, but for now, just keep in mind that sometimes when you have lots of decimal places, the math gets a little wonky. Anyway, I can clearly see now what mistake that I've made, which is that the value of my modified integer, I wanted that to be 666 so that I could then move the decimal point back and keep everything. But the value of my modified integer is only 6. Can you spot exactly what mistake I've made? I'll give you a second to see if you notice it. If not, you'll notice that when I took my modified integer, it was supposed to be the integer representation of my modified double, not my original double. So my modified double is now going to give me what I want. So if I run this, enter 6 point, bunch of sixes. Okay, let's see. There's still something not quite right here. When I take my original number, my 6 point, all the sixes, I multiply it by 100, and the reason that I'm doing this is because I want to save exactly 2 decimal spots after what's there. So that gives me my 2 extra sixes that are in here, and everything else is stuff that I want to cut off. In order to cut that stuff off, I'm going to be converting everything into an integer. By converting it to an integer, I cut off all the decimal points that I don't need. So great, I have 666. I want to get 6.66 and stop, because that would be great. That's exactly what the question's been asking for. But it looks like I made a mistake here, because this still isn't working. Why is that? I can explain why. So my modified double is what I want to have 6.66. But here is the problem. If you remember from before, when you do integer division, it cuts away all the remainders. So when I divide 666 by 100, well, the 66 remainder just gets thrown away. So that means that in order to actually have this division keep track of the decimal points and store that in my modified double, I need to make it so that this value here, the integer divided by integer, actually is a decimal thing. And in order to do that, I could either convert this into a double, or I can actually just take 100 and make it a floating point number, a double, by doing 100.0. You know, mathematician will tell you this is the exact same thing, right? But a programmer will tell you, actually, this is going to affect the outcome. 6 point, bunch of sixes. And look at that. The value of my modified double is 6.66. And the only reason I was able to do this is by taking advantage of the fact that integer division will cut away remainders if you are doing it properly. Or sometimes if you don't want it to, it will still do that anyway. And that was what we were looking for, I believe, yes? Double variable as a dollar amount. Now, I guess if we want it to be the proper dollar amount, we should, output it as a dollar amount. So your double as a dollar amount is $, and then the modified double. And now at this point, we don't need to have any of these other output statements anymore. So this one, or this one, or this one don't need to be printed, because all we care about is the final result. And look at that. My double as a dollar amount is $6.66. So this program was a little tricky, but it turns out there's actually an even better shortcut that we can use to save all of this trouble and do things really, really quickly. So what I'm going to do is I'm actually going to make another attempt at this, which I'm going to do it real quickly. Turns out you can take cout and tell it that you want a precision. Let's say that I want this to be 3 digits. I can just say cout your double as dollar amount is, and just give it the number. Now, bear in mind, this doesn't quite do exactly what we were asking for, because this is only really going to work because I'm doing 6.66 something. So if I was doing a larger number, you might not get what you're looking for. But the precision, function of cout allows you to set how many significant digits that you want. So let's give this a shot. 6.6 repeating. And this time it's going to round, because with significant digits you round to the closest. So instead of getting 6.66, I get 6.67. I think that this is the longer part of this is a better answer to the question, because you'll notice that there is a little bit of a problem in that if I don't enter 6.66 again, say I enter 101.55555, this is not my double as a dollar amount, right? This is just my my double with 3 significant digits. So there are obviously ways you can figure out exactly how many digits you need to include, but it's a lot more annoying than just taking advantage of our integer division to solve the problem. So end result, let's not do this. It's there if you want it, but for this problem in particular, we're looking for taking advantage of integer division to cut away remainders and give ourselves rounding through that through this little tiny algorithm that we've written. So that's it for this video. Hopefully you found this to be useful. If you have any questions about it, feel free to message on Slack. I don't tend to check YouTube comments very often, so writing stuff under this video is probably not going to get you responses very quickly. But happy to answer any questions about what I did, and I will see you in class. Bye-bye.